Okay, I think it's almost the time to start today's very first lecture. Beginning with some quick introduction, my name is Nadim Abbas, and I will be teaching this course together with Khailos. He will be the teaching assistant in this course, and if you have seen the time plan, so we have every week on the same day after the lecture, the 2 hours lab sessions. So the basic idea is, the lab sessions are, if you need some help with the programming assignments, so the Sherry will be there, so you can ask the questions over there. So today's lecture, it's more about the introduction of the course. What are we going to learn in this course? What are the different activities? So the basic, this course, as we look at in the contents, I will go quickly towards the contents. It's like basically we have 3 parts. The one part is about quick overview of the Java programming. So it's not like an introductory programming language course. So I will not start like teaching the basics of programming. So it's more like a refresher or an overview of what the programming is, what object-oriented language is, and how you write Java, the code in Java. And the idea is, since it's like an introductory level, the first level course, and the Java is often used in different courses in these institutions. So the idea is to give you an overview. If you have not already worked with the Java, so you can just get fresh hands, and even if you have worked on it. So, but if you have already programmed in Java and or even in some other language, then I think this first part should not be very difficult for you guys. It should be rather a walk in the park, I will say. So, and today's lecture, since I'm starting with the introduction to the Java, like the basic programming concepts, what are the variables, data types, control statements, arrays. So it might look very simple. And if you're familiar with these concepts, maybe you feel kind of boring, but I promise there will be more advanced concepts coming up after today's lecture. And then the second part, when we are done with the Java things, the second part is more about introduction to data structures and algorithms. So what are the data structures and what are the different kinds of data structures, like we have linked list, stacks, and queues, and why we use these different data structures, under what kind of conditions you should select one data structure, and if under when should you use stack, when should you use queues. And then we will also look at the various algorithms. And we will also look at the time complexity. In simple, I will say like the time complexity is kind of like estimate like how efficient one algorithm is, or how efficient in terms of time your program is, so that you can analyze and choose among different algorithms. And then there will be some part about formal languages. So what are the formal languages, and how can you define what are the basic constructs, like for example, in every language we have certain kind of rules, and what the language is composed of, and how you can define formal language. Okay, again, it's not a beginner's level course, so if you have not studied any programming language, you might have to work a bit harder in the first few weeks. So these are the objectives, and they are pretty much already displayed on the course homepage. So I will not go into the details, but if you have anything, if you have some questions, of course you can ask either during the lecture or after the lecture, that why we are taking this course. What is important is that you should have access to the course homepage, because that will be our main medium to communicate with you guys. And all the updates, like the assignments, will be published over there, and you can also use the forums over there. So, and also, if you have been registered, if you have been admitted to the course, that doesn't mean that you have an access to the course homepage. So it's very important that you should have access to the course homepage. So I don't know if you have all of them have already access to the Moodle homepage. If not, that could be that probably that you have not registered to the course in a right way. So you should, I mean, you can do the registration online using the LNU web, or you can contact some of the teaching staff that we can help you with that one. And if you see on here, we have like just the different forums. So we already have started seeing some questions from you guys. And so we have like 4 assignments planned in the course, and for each assignment we have like a questions forum, so you can put the question on here. And also, I mean, since in this course we have a distance students, the students that are joining the course from the different parts of the world, and we are streaming the lectures online. And for those questions, for those students, since the system doesn't really support, it supports only one way of communication, they can hear me, but I can't hear their questions. So, and for that, I have already given the instruction that how can they, if they have a question, so we have a Slack forum for that, so they can put the question. And I will try to look at the questions during the break, and we'll try to answer them afterward. Okay, so that's about something about the course homepage. And yeah, and if you have problems, probably you can send an email. And then about some plan for the whole course. We will have about 8 lectures on the different contents that we already seen. And we will have 4 individual assignments. So it's important that all the assignments are individual ones. And then we will get 2 hours lab session as a support, Moodle forum. And as I said earlier, Carlos is here, so you can contact him. There will be 1 written exam in the end, and the dates are already in the time plan, and I will also publish the dates for all 3 exams, so that you can plan the things accordingly. And there will be like 3 chances for each assignment and written exams. And there is some information about what the tool that you need. So basically, we don't need something very advanced. We just need a JDK as a, the tool to develop that supports your programming in Java. And also very important that sometimes people confuse JDK with the JRE. So you don't need the JRE on your system. The JRE is like Java runtime environment, so that you need to run, if you're not developing, if you're not writing the code or compiling the code, then maybe you can run your applications or the code written in Java only using the Java runtime environment that provides you with the Java virtual machine. But if you are writing the code, you are working as a developer, then you need the whole JDK things. And we recommend the Eclipse, but it's not mandatory. If you prefer some other, you can write your Java code even in a notepad. Yeah, if you like to, but we don't support or encourage. But sometimes I came across the students, they got confused with the Eclipse. They find it very, in the beginning they see like, yeah, it's quite complicated. I don't understand this thing. It's up to you guys, okay? So that was some quick introduction about the course and what things we will be doing. And so if you have a question so far, of course you can ask now. Otherwise, I will proceed with the very first part of the actual course, okay? So yeah, we are already ready to swim in the world of Java. What we do in Java, it's basically, we can summarize the whole thing in 3 steps. We write the code, and when we are done with writing the code, we save it, of course, in some file, and then we need to translate that code because, the Java, just like other programming languages, it's like a high-level programming language. And as you are familiar from the other courses, might be like the computers doesn't understand something other than the machine language. So if you have written a code in some high-level language like Java, C++, or any other, then you need to translate it. You need to compile it into a format that is understandable by the computer. And I will not go into the details why we need the high-level languages because, programming in the binary 0, 1 would be, yeah, not fun for the human beings. So that's why the earliest guys helped us by working on and providing us with the constructs like modern day languages where you can write codes quite similar to our natural languages. And the code that we write, there is some terminology given over here that the code written in some high-level languages like Java, we call it like a source code, and we save the file that you write in Java. You need to save them with the extension .java. That makes that this file is your Java source file. Okay, and then the second step is, for example, if you have written a code with the name myprogram.java, then you need to compile it. And what does the compiler do? It translates your Java source code into something that is understandable by a machine. And before Java, the problem with the earliest languages was like, for example, with the C++, that if you have compiled a code in one machine, then you cannot run it on another machine, because every machine has its own machine-specific set of instructions. And also, I mean, depending on the different platforms. So if you have compiled for Windows, you cannot run it maybe on Unix or some other platform. So then you need to, I mean, recompile it. So the Java, they provided with the middleware thing with the name of Java Virtual Machine, and with the intermediary code format that they call it bytecode. And the bytecode is something that is, we can say that platform independent. You don't need to worry about, if you have written, the Java provides you with a compiler that translates your Java code into the bytecode. And the bytecodes, they are normally stored in the .class file. So if you have a program written in myprogram.java, and when you compile it, the compiler will generate another file with the name of, having the same name, but the extension will be .class. So whenever you come up with the .class files in a Java environment, so then those .class are your bytecode files. Once you have got the bytecode file, you can run it on any machine that supports, that has a Java virtual machine. And Java provides you with the Java virtual machine for all the different operating systems. So you can have a JVM for Windows, you can have a JVM for Mac, and the JVM for other operating systems. Okay, so that's, I mean, pretty simple thing over here. And this is, as I explained earlier. So you write, as a developer, as a programmer, or as an end user of Java, you don't need to bother about this stuff. This is provided to you by the Java guys. So you just need to write, you need to learn the Java language, and then you write code. And if you have a compiler that have generated the bytecode for this one, and then you can run it, that bytecode on any platform using the JVM. The only thing that you need is that you need the right JVM for that platform. Okay, and sometimes I mean, and also if you have a, there is often a confusion between different terminologies. Like we heard about JDK, the Java Development Kit, and then JVM, Java Virtual Machine, and Java Runtime Environment. So the difference, does anyone help me to explain the difference between these three? Are you already, I mean, I assume that some of you have already worked with the Java. All of you have already worked with Java, or there is some new guys as well? No. So can someone help me to explain what are these different fictional things are, like, not the fictional, but these different terminologies are, JDK and JVM and JRE, what are the differences between them? Okay, I mean, it's not something that really important to know to be a programmer in Java, but you can see that, I mean, the Java Development Kit, it's like, you can see it's like a bigger package that provides you with the tools that are needed both for development to write the code, and like debugger and compiler. And then the second bigger thing is the Java runtime environment. If you're not a programmer, then you don't really need the whole JDK. Then maybe if you are running some application written in Java, if you are like a client that uses the Java programs, then you can maybe use only the JRE, Java Runtime Environment. And that provides you with the class files and the Java virtual machine. So it's like an interpreter or the environment where you can execute the bytecode. Okay, and once if you have a JRE, JVM is a part of Java runtime environment. So it's like a virtual machine. It's like, it sounds like a machine, but it's not really a machine. It's like kind of a software or a virtual machine or a fictitious computer that supports running the Java code. Okay, then a few basic simple things. I mean, they're not very advanced. As I said, that today's lecture will be not very complicated. So it will be rather trivial things, that what should be the files and source code. So in every, I mean, whenever you write a code, Java, you need to save it with the extension .java. And for every executable Java program, you need at least one class. You should have at least one class with a main method. We will see what are the classes later on, because in the next lecture, we will learn about what is objects-oriented programming and what are the objects and classes and why we really need them and what are the different concepts in object-oriented programming. So right now you can consider class is like a basic fundamental building block in object-oriented programming. And using the class, you can define the behavior of your objects, because in object-oriented programming, we model and solve our problems in terms of objects. And you need to define the objects. You need the class definitions, okay? And every class will have some name. And what is important here is that the name of the file should be the same as the name of the class. So if you have a class name as a player or as a vehicle or a human, then you should save that file with the same name. Okay, and as a convention, the file names or the class names starts with the capital letters, and then you have other things in the smalls. And then, since we talk about, I mean, you have often heard about Java as an object-oriented programming language, okay? And the basic ideology of the object-oriented programming language is like, because we use programming language or any programming code to solve our problems, okay? It's like a problem solving. And the problem, since we have a problem that's coming from the real world, and in the real world we have a lot of different objects. Okay, so for example, if we look at around in this classroom, we have a number of different objects. We have a projector, we have chairs, tables, walls, and a lot of different objects. So, and each object has certain properties, and it could have behavior as well. So for example, if a teacher is an object, and every teacher will have some behavior, what does he do? He teaches. Teaching is perhaps the most important behavior of a teacher. But other than that, he walks as a human being, he can run, he can speak, he can look. And then there are like some attributes as well that distinguishes one object from the other object. So for example, every teacher might have a unique some identification number, like a personal number, and then is a name. So the same, like if you are, when you are creating, when you have a problem, you try to identify the objects, okay, and then you try to model that problem in terms of objects. What are the different attributes of that object, and how do the different objects interact? Because when we have a problem, we have the problem, and we solve problems by interacting between the different objects. We send the messages. One object performs services for some other objects, and one object we consume services, we provide services, okay? So, and the basic thing behind each object is a class. Every object belongs to some class. So, when we are programming in Java, in any other programming language, we need to identify the objects. We need to identify the attributes and behaviors. We will talk about this thing in the next lecture in more details. But since today we are talking about some introductory level concept like data, and it's very important that without that, I mean, if you're solving some problem, you will be dealing with some information, and that information is represented using variables. And so this is what we have over here is that data associated with the class or object is stored in variables. Okay, we will see what the variables are later on. And then the behavior, what an object can perform, what activities an object can do. For example, if you have created an object like a robot, what can he do? Okay, so that behaviors we specify or define using methods of a class. Okay, and if you have learned about some, if you're familiar with other languages like C++, in different languages we call the behaviors or methods are represented by maybe functions or procedures. So they are in Java we call them methods instead. And then every method is a set of statements, and the statements are like some basic instructions that we need to perform. So, for example, if you want to declare a variable, integer sum, we will see what is int, and then these kind of things, these are the statements. And every method is a group of certain statements. So we can say that basically each program, not only in Java, but in any programming language, it's basically a set of instructions or set of statements that you give to the computer. Other than statements, when we see a program, example of a program here, for example, you can have, I mean, the statements are, we said that statements are the instructions that we give to the computer to perform some operations. But sometimes it is also nice to have some information in the programs that is not really for the computer, but it is for yourself, or maybe for the other human users, for a documentation purpose. Because if you have, you might have experienced that you write a program, you write a code, a complex kind of code that you have written maybe 2-3 years ago, and after 2-3 years ago, if you look at your own code, it becomes very tricky for you to understand what this piece of code is doing, why I put this line over here, why I created this variable, why I passed 3 parameters to this variable. So this, I mean, it's very easy to forget about that things. And also, I mean, when you work in companies, you don't work always. Maybe after 2 or 3 years, you find a better opportunity and you move on. But your code remains there, and somebody comes to take your position and replaces you, and he becomes responsible to maintain the code that was written by you. And you can imagine that how complicated it could be to understand somebody else's code without getting some information in the form of comments or documentation. So it is always a nice practice that whenever you are writing a code, that you put some comments, you put some additional information, and that information is totally for you, it's not for the computer. The computer will ignore that information. And how can we tell that computer that this information is not for you to perform any operation? For example, who writes this code? It could be important if you, I mean, if you are working in a team and there are a lot of different guys. If, for example, if you are working in a company with 100 different people developing an application, and in the end, if you don't put these comments and you combine the code from all the different guys, without finding who wrote this code, it will be very tricky to manage or to upgrade that code. And then you can put I mean, of course, you are free to put whatever you want to do. It's a simple program. In this kind of program, it maybe doesn't make any sense because it's a simple only 2 lines, and you can, by looking at the code, you can see that this program is actually adding 2 numbers. But there could be a more advanced, complicated scenarios where it could not be just looking at the code and finding what has been happening over here. Okay, and the Java, you have like Java supports 3 kind of comments. You can have comments like single line comments with the forward slashes. And as I said, the comments are ignored by the compiler, so they are not considered as Java instructions. So it doesn't really matter whatever you write over there, but it should be meaningful and useful. And then you have a multi-line comments. For example, instead of putting this forward slash, instead of putting this forward slash on, if you have like 10 lines as a comment, so instead of putting this forward slash on every line, you can just follow this multi-line comment style. Okay, and then there are comments for the Java documentation. So if later on, if you want to generate, if you want to use some Java documentation tool that automatically will generate some kind of manual or helping document that we call a Java documentation or API documentation, then you can use this Java documents at the top, where you can provide maybe the meta information, that what is the name, who was the author, and why this code was written. Yes?
Yeah, I'm wondering for the assignments, if we create a very simple method that is quite self-explainable,
Yeah.
Should we, in that case, write comments, or can we skip it in that case?
I think we have a good guy to answer this question over here. What do you think, Shailos?
At least the general description is always good.
Yeah. I mean, it's always good to put some general description, because this is a question which has no definite answer. Okay, it's always encouraged to put at least some kind of comment, maybe just 1 or 2 lines. Of course, the more details, the more better it is. But it will be nice. I mean, if something is happening, if you think it's only like 2 or 3 lines of code and it's pretty, and if you have provided maybe if you have described this thing as a multi-line comment in the beginning of your code or class, so there is no one-liner answer to this question, to be honest. So, but to be on a safe side, because if you have put the comments, if you have well-documented code, is always encouraged and appreciated. So it's better to put comments than not to put comments in your assignments. Okay. Okay. Then here, if you look at, it's just some simple description of what is happening over here. So this program, it's a self-descriptory slide. So here we have a class, a program that contains class add numbers, and then we also have a package declaration here. That's not really a mandatory, but also a good practice to organize your code. So you can see the packages just like kind of folders in your file system that you can use to organize. It's like a namespace that you can use to organize your code that are together. And later on, if you have defined one package, by defining a packages, you can import the packages as well later on. And then we have if you look at this class, we only have a main method. Okay, and this is the Java syntax: public, static, void, main. The public, static, and void, these are all like modifiers. Okay, we will learn about what does it mean by public in the next lectures, and the static keywords as well. So, and then you have some set of instructions, statements over here. And as a comment over here, you have written that a program that adds 2 numbers and displays their sum on the screen. As I said earlier, every executable Java application need to have a class that contains the main method. If you don't have because the main is the starting point for your application. The first line that you write in your main method will be executed first. Okay. We can see a quick, simple example. I mean, it's not very complicated here, but we can also look at, for example, I already have Eclipse here, and I already have the programs written here, the same one. But just to show you quickly, if you want to create a new project, you can use file new Java project, and then you can choose some meaningful name what this project is for example 2DV 600 lecture 1, and then you don't really need to worry about this. You need some execution environment, and that's all. By creating a project, if you see the source, there is nothing. It's like an empty Java project. But as I said earlier, to create a Java application, you need at least every Java program need to contain one class. Okay, so the next simple step could be like you need to have at least one class. So you can do it from here, file new, or you can use some shortcuts. Okay, and if you're not familiar with the Eclipse or Java, I mean, you can find a lot of tutorials and the YouTube videos. So it's not a rocket science. So you'll try to do it yourself, and if you find your problems, Charles will be there during the lab session, so he can help you with how to create Java programs, a Java project, and work with the classes. And here, if you want to create a package, you can of course create specify the package name. Okay, so for example, basic or whatever you want to say. It could be something like LNU.2DV600. Now, if you see, the package name is not valid, 2DV600. That means that you cannot start your package name with the digits. DV600 should be fine. Next, we need to define the class name. Let's say hello, simple one like hello world. Often you have familiar, the first program that you do. And then if you want to generate, I'm not talking about superclasses yet, but it's like when we learn about object-oriented programming and inheritance. So then we will talk about superclass concept as well. But so far now you can assume it like it's in Java, every class is a subclass of object class. So that the object class is by default a superclass of every class that you write in Java. And then you define, we need a main method because we are going to create an executable application. And that's all that you need. And if you click on the finish, you will already get something like this. Okay. And that's if you see that already generated code. So that's a standard format for a Java main method. You don't need to really change this thing. And as I said earlier, we will learn about these keywords later on. And here, whatever you want to do, if you want to create a variable, okay, integer marks, something. And then if you want to print, you need the println statement. And in the Java, I mean, if you want to display a message on your console screen, because normally the basic thing that we use in the program is that we provide some input to the program, we provide some data, and the program provides some output. Okay, and the output thing is I mean, if you are familiar with the input and output, that it's like you have a console, you have some screen where you have some information. And if you want to print some information on your console, for that we use system.out.println statement. System is a Java class, okay, that provides you with the features like input stream, output stream, system error, and the out is an object of a print stream class. You can Google up, you can look at, I mean, if you, also it's very important that when you are learning some language, you should have an access to the API documentation, because it's a good tool to learn about different things. So for example, the Java, we have latest version is Java 12. So, and here on this URL, you can Google it, Java 12 API documentation. And then you can find all the different modules and packages. The module is a new thing in Java. It was not there like, I don't know, a few years ago. But now they organized their packages into another higher level hierarchy of modules. But for example, if you want to know about system class, java.lang.systems, you just write system here, and it will suggest to you this thing. And here you can read about what this class is, okay, and what are the different members, the fields. We will learn about what these fields things are, or the members are, when we go in forward to this course, most likely in the next lecture. And here you see that this out thing is over here. And if you see this out, it's basically a print stream object that connects you with the standard system output stream, okay? And the stream is like the data which is flowing from either from input device or from the output device. So you can read about these things. And if you go into this print stream class, you will see the different methods. For example, it has the print methods, and the one that I am using here is a println. And the println method come in different variants. So you can use it, prints, and you can see what this method performs. You can read about here, prints an integer and then terminates the line, okay? So for example, if I go back to the code here, whatever you want to print, if it's just a numeric value or if it's some variable, you can simply put this variable name. Or if you want to print something more as an information, you can put that information within the double quotes. Okay, for example, this is our first program that prints a variable. And this plus is like a concatenation operator that connects the message that you write. This thing that you write in the double quotes, in Java we call them strings. Anything that you write within double quotes, they are treated as strings. And strings, they are simply a sequence of characters. And now, for example, we have just this basic stuff. Okay, we don't want to do anything complicated right now. We have written the code, and now you want to execute it. So when we run this code, here it shows the output. This is our first program that prints a variable 100. And in case if you have not followed the Java syntax, for example, in Java, most of the statements, I think even every statement ends with a semicolon. If you don't put the semicolon, your program will not compile successfully. it's already the Eclipse will already give you the compile time error with this red sign. And if you go to this red sign, you can find some suggestion as well. So syntax error, insert semicolon to complete statement. Okay. So it's always, I mean, good. That's why we encourage to use the IDs instead of using simple your notepad programming. Yeah. This is again some basic steps. So you need, if you have a Java program, you save it in Java file, and also then you have a Java compiler that generates you the bytecode, and that Java bytecode is run by your virtual machine, and the virtual machine is used by the operating system. So you have a operating system specific different virtual machine. So this is just a diagram to understand the basic flow, like how a Java program is compiled and executed. What are the things that are involved over here? And if you have any questions, if you don't understand, I mean, you can find a good description about each of these things in the commonly available textbooks, and even the Java tutorials, they can explain you. Now, I mean, few of the most commonly used elements in any programming languages are like the variables and the data types. Whatever language you are using, you need to hold your data, to represent your data, you need some variables. And what are the variables? As the name indicates, it's like something that can vary. It's like a placeholders to where you can put your data, and then you can access that data using the identifiers. And to create a variable, because in one program you can have a data of various different types. You can have a numeric data, you can have alphabetic data, and even in the numeric data you can have a data with decimal points, and you can have a data without decimal points. So if you want to create a variable, you need to specify the type of the variable. This is the general syntax, how you can create a variable, or how we can define a variable in Java. To create a variable, we need to specify the type, then an identifier. Identifier is like a tag that we use to name. It's like a name, all of us, if we consider ourselves as a variable, so we have some identifier. So for example, Nadeem, in my case, my name is like an identifier for me, by which you people identify me. And it's the same like with all of us. So we have some identifiers, and even and that identifier should be unique if you in one program, in a one execution. So for example, it means that if you have used age, you cannot use it to name another variable, because then it will be a confusion which variable you want to access. And also, when you define a variable, you can assign some value to it as well. But that part is, assigning a value to a variable is an optional part. You can you can specify the name and type and assign the value later on as well. But for example, you need a variable for price, but maybe you don't know the value at the beginning of a program. That value will be computed later on, depending on number of different sub-factors. So in that case, you can leave the initialization part empty. So in simple, to create a variable, you need to specify, you need to know the type of the variable and the variable identifier. The next thing is the data types. If you have a data, that data must have some type. Okay. So, and in Java, we have two basic classes of data types. We have a primitive data types, and then we have a reference types, data types, or the user-defined types. The difference between the two is that the primitive types, they are provided by the Java. They are already defined in the Java language system, and they are based on the simple, very basic data, like numeric kind of data, and the strings are not the string, but the characters. And then so Java provides us with 8 primitive types. You don't need to define them, you just need to use them. Okay. The 4 integer types with the name byte, short, int, long. And I mean, that varies in sizes. An important concept that is associated with the data is the memory. Because whatever files, whatever data we give to the computers, they are stored somewhere in the computer memory. Okay. It means, and you can choose, for example, for some kind of data, you know that the size of that data will not be, that data could be only from maybe 1 to 100. For example, the weekdays, we know that the weekdays could be 1 to 7. We can represent the weekdays from, like, 1 represents the Monday and 2 represents the Tuesday, and we can code it just with the 7 values. So it means that we don't need a lot of memory space. But for other kind of values, for example, if you are running a company that deals with a lot of, that has a budget in billions, and then you need, maybe you know that our application or program is going to deal with higher, larger values, or in the mathematical or in the scientific applications, where you are maybe doing programming about the stars and the planets, and the computing the distance between the planets, and that could be exponential values. Then you need a larger memory. Okay. So the Java programming language provides you with different options. The byte is the byte type is the one with the smallest memory option. It's only like the byte, 1 byte. It occupies 1 byte in the memory. But obviously, then you can only store smaller data. The lowest you can find the data range in the various books, like how much maximum value we can store in a byte, and the same like the short, int, and long. So in short, we usually use int. We don't. But if you are writing a memory efficient application where you have a limited memory available, then you should be very careful about your choice of data types. Because, for example, if you are developing an application that will be used on a wearable devices, cell phone, even smaller, like smartwatches, which have a very resource constraints hardware and a limited memory. And then if you have written your program that consumes a lot of memory, then it will affect the performance of your application. But I mean, as a student, we usually work with the int type. We don't really bother about until we are concerned with the memory. But it's always good to know that why these different options are. And then if you have, I mean, the integer type is simply to represent the numeric values without decimal points. But if you have numeric values with the decimal points, then you use the float or the double. And then we have a character type, and in Java, we represent the characters within the single quotes. So for example, I think we have a program quickly to show you how can you, it's a basic stuff, nothing complicated over here. So for example here, if you have a character, if you want to represent single character, then you can define a variable of character type. So it's same like as we saw in the previous slide, we have a type, we have identifier, and then we have an initial value for that. And if you have like numeric values, Yeah, you can use int long. And then we also have a Boolean type in Java. It's also a primitive type that you can use to store, represent true false values. And often we have a situation where we have a yes or no kind of things. And if you want to represent this kind of data, which is either yes or no, true or false, then we can use Boolean. For example, if you are a student or not. Okay. I think it's no, we can do it after this. And then we have a reference types. Okay. And these are the reference types are the types that are defined by Java classes, that are defined by the user. So if you have a data, more complicated data, more complex data, which is composed of more than one values. For example, we have a data about student, and the data about student is not consisting of not single value. It is composed of multiple different attributes: name, address, course, date of birth, so things like that. In that case, we cannot represent data about a student using a one single primitive type. We need multiple different data types. And since we have objects, in the object-oriented programming, we earlier talked about that we model the things in terms of the objects. And in the objects, and we know, to define an object, we create a class. So basically, whenever you create a class, the objects of that, a class becomes a type, and the objects of that class becomes the variables in the sense of if you compare them with the primitive types. So we can say that each class defines a new reference type, and you can use it as a type similar to the primitive types. So for example, if you have defined a class for the student, and if you want to create an object, you have to define the same like we have defined earlier for the integer. So for example, if I switch to this the whiteboard mode over here, because that's not important for you, but it's important for the guys we have online over here. Then I have to go to the whiteboard over there. So for example, we saw that if we have a primitive type, we need the type, and then we need identifier. Okay, for example, integer age, and then optionally some value like 20 semicolon. Similarly, if you have defined a class like Java class student, and I don't go into the details what we have defined inside, but now this student has become a reference type. We can use it as a type to represent our data about the student. And in a similar way to the primitive types, we can specify the objects. We can create the objects of type student. We need a reference variable. We say that student S1, and then there is a special way to create objects, because student is a class. It's not like a simple primitive type to which we can assign the value directly like here. We will learn about what are the objects, and but for now you can simply see like this, that you need a new keyword. This is how we create an object of a class. So this is a Java syntax. In the primitive types, we simply define a variable type and assign a value. But with the Java reference types, because you can have different reference types. You can have a type for a student, you can have a type for a teacher, you can have a type for a doctor or whatever object, robot. But you need to specify what this object belongs to which class this object belongs to. And you do this by specifying it when you are defining the reference variable to that class object. And an associated concept with the types is type conversion. Often in our programs, we have statements that involves data of various different types. So, for example, in one statement, you have one variable of type integer and another variable of type maybe byte and another variable of type double. Okay? So, when you have variables or the data of different types, the Java will automatically, sometime it will do implicit type conversion, it will transform one type into another type. Okay? So, this process where one type is converted into another type is called often type conversion or typecasting. Okay? And by default, if you have not specified the type by yourself, the smaller in size, in memory requirements, types will be converted into the more larger ones. This is called like something like a widening type conversion as well. So, for example, we saw that if you have two variables, one is byte and another one is short, so the byte will be converted to the short, and so on. Short will be converted into integer, long to float, and float to the double. But if you want to do the reverse, that is also possible, but that you have to do it by yourself, that you have to give some instructions. And how can we do it? If you, for example, if we have a double type variable here and we want to assign this value to integer type variable, okay, then we know that this d is of type double, but we want to assign into the integer. We can specify this after the initialization sign within the parentheses. And this could be done also with the because characters are internally stored represented in Java as numeric values. So, you can also do these conversions between integer and character types. Okay, I think we are halfway in the lecture, so let's take 10 minutes break, and after the break we will continue with the operators. And if you have a question before that, of course, you are welcome.
Yeah, but you need to know what's your lesson plan.
But a former student introduced I3 and the works.
Probably Gnome.
Yeah, I think it is.
Okay, guys. I think. Sorry to. Yeah, maybe you can take it during the lab session. Yeah. Okay. So the next thing we have the operators, and I think you all are already familiar with the operators, not even from the programming, but maybe from some mathematics. We have the arithmetic operators. So if you want to perform some mathematical operations, add the values, multiply, subtract, then you have the simple arithmetic operators that we mostly use for mathematical stuff, addition, divisions. And yeah, and we have this modulus operator. It's also now common. I mean, it's not like the percentage sign to find the percentage value. It's if you divide two numbers, then if you want to find what is the remaining value after the division, so then you can use this modulus operator. Other than this, we have increment, decrement operators. Can someone explain what is this plus, plus, minus, minus? Can someone help me with that? You add one. So for example, if you have a variable with the value like 10, and if you want to increment it by 1, you can do it one way is like, okay, 10 plus 1 or variable a plus 1. Another way could be like just a plus plus. That's something from the C++, I guess, similar to that one. So, okay, and if you want to decrement the same, you can do it minus, minus. And then we also have compound assignment operators. So, for example, the one way to assign a value is like, as we said, that a is equal to, for example, if you have a variable and you want to assign, you want to add some value to that variable. So, the one way is like you write a is equal to a plus 5 or plus 10. On the other way, you can write it using this compound assignment operator. So, for example, let me see if we can do it over here. So one way is like here, if we want to integer a is equal to 1 plus 2, and then another way is like if you want to add further value a plus maybe 5, that's another way. But you can also do the similar thing doing plus is equal to, the effect of these two statements will be the same. Okay. So this kind of operators where you do, yeah, addition or some other arithmetic operation together with assignment, we call them compound assignment operators. Okay. And you can use it not with the plus, but also with the other operators. Then we have relational operators, and as the name says, relationing, if you want to compare the values, less than, greater than, less than equal to, greater than equal to, okay, not equal to. So for this kind of operations, we use relational operators. And the important thing to know is like the equal sign, that's not for the comparison, that's for the assignment. If you want to compare two things, so for example, if you want to compare two variables, if a is equal to b, if you use a single assignment, that will assign a value of your right hand operand or the variable to the left hand. But if you want to compare them, then you have to use the double equal sign. So the double equal sign is used for the comparison. So if you want to compare whether the value of a is exactly equal to the value of b, then you have to use double equal sign. And then we also have a not equal to, if you want to say like whether, if you want to make some check that involve that if the two values are not equal to, then you have to use this one. And sometimes we have situations where you want to combine depending on like based on, like, for example, if we have a kind of situations where you want to like combine the output of one with the another one, if this is true and this is true. So for this kind of operations, we use the logical operators, and or not, especially when you have the booleans, so values like true, false. So for example, if we want to say, like, if we want to compare, if you want to decide like whether a student has passed or not, so you can say like if marks greater than 40, or let's say whatever the benchmark is, then you don't need any logical operator. You can just do it with the relational operators. But if you have to combine that thing with some other condition, so for example, if marks greater than 40, and then another condition is and all assignments or something like that that are passed. So then you can combine two conditions or more than two conditions using these logical operators. And the AND requires, if you have a two or more than two conditions with the Boolean outcomes, true, false, the AND requires that the both expression should be true. If one of the Boolean expression is false, the whole effect will become false. On the other hand, the OR works the opposite way. If one of the expression is true, the whole expression will become true. And NOT, if you have a Boolean value, the NOT will negate it. It's okay. It will invert it. If it's a true and you put a NOT, it will change the true into false and the false into true. And then we have an exclusive OR. Okay, and the effect of exclusive OR is in the simple OR, if one of the value, any one of the two or more value is true, the whole expression will be true. Only it will be false when both are false. But in the exclusive OR, it will become true when both expressions have the same value. Okay, even if it's like true. No, now I'm confusing this. Exclusive OR, it's not like when the false, it doesn't become the false. When the one of them is true, it becomes true. If both are the same, either true, exclusive or true, if both are true, the whole effect will become false. Understand? It's like, for example, maybe we can use the whiteboard here. But I'm then afraid that will the camera will come back or not?
It's supposed to. No?
It's supposed to, yeah.
Hopefully. Otherwise, you have to.
Okay. So, for example, if we have value A and B, and then we have true, we can have different combinations, true, true, false, false, and then false, true. That could be the different combinations with the two values, okay? And then if we said that if we have A and B. In this case, for the AND, we said that the outcome will be true only when both values will be true. So in this case, it will be true. For all other cases, it will be false, false. On the other hand, if we use the OR here, and the OR checks even if only one of the value is true, the effect will be true. So this is true, and since one value is true, so this will be true, and this will also be true. And this is both are false, so it will be false. But then with this exclusive OR, simple to remember is that both should be different. They should not be same. That's a simple rule of thumb. So here they are same, so the outcome is false. Here one is true, other is false. One is false, other is true. Both are false. So when both are the same, the exclusive OR will give you the false. Otherwise, it will be true. Okay. Now does it turn? Yeah. Next we have the operator precedence. It means that when you have like, for example, even in basic mathematics, if we have like in one expression, we have a multiple operators. So usually we have a left to right rule, but some of the operators have higher priority than, for example, multiplication and divisions. They have a higher priority than plus and minus. So if you have a multiplication and addition in one statement, the multiplication will be performed before the addition. Okay. So which of the operation will be performed first? This will be decided by the precedence of that operator. The operators on the top have the highest priority. So for example, if you have a statement that involves this increment, decrement, and then it also involves some of the lowest level operators. So before, the value will be incremented first, and then other operations will be performed. Do you understand? So it's quite simple. So because I have to cover more better concepts, so I will not go into the detail of this simple stuff over here. But if you have, of course, if you read at home and if you have questions, you are more than welcome to ask us. And then we have this plus operator that we use. We already seen this with when we do this println. This plus operator can be used together with the strings, other than just performing the addition with the numeric value. So when it is used with the numeric or decimal point values, it performs the addition. But when it's used, when one of the operand is a string, then this will be used as a string concatenation, that it will join two of the strings together to get a new string. We already talked about the identifiers. So they are simply, I mean, the labels are the words that are used to identify different entities, and that entities could be variables, methods in your programs. Okay. And even the class name is also an identifier, and package name is also an identifier. So they could be, and there are some rules. While defining a variable, while naming a variable, you can use alphabets and digits, but your identifier name should not start with a digit. Okay, the digit can be used in the middle, in the end, but not at the very first position. Other than alphabetics like from A to Z and numeric values, you can use underscore and $sign. I don't know why the reason is why they allowed these two, but that's the Java rule, that you can use underscore and $sign in the identifier names, but not other characters. Okay. For example, if you have used something like 22x, this is not accepted. But you can use it other ways around, like x22, or maybe if you put underscore before 22 or something like that, then it's okay, then it's no problem. And then we also have some reserve words or the keywords in the Java language. Every language has some reserve words that it has reserved for its own set of instructions, that you cannot use it for the construct that you define by yourself. So you cannot use these, the simple to remember is that you cannot use these reserve words or the keywords for your own kind of entities that you define. For example, the classes that you define, you cannot name a class like else extends final. So it should be something else. So it's just a simple basic language rules, like every language has its own rules. Then an important concept, this is I think the more important thing to learn from today's lecture is like the arrays. We have seen about the basic data variables, data types. Arrays is a form of, it's like a data structures that allows you to create to store multiple values of same type. Often, for example, if you want to create 10 variables of type integer, one way is that you can use write 10 different statements like integer a, integer b, integer c, and assign values. But for example, if you have 100 students in a class, and if you want to create a variable that stores grades for the 100 students, then it means that you need to define the 100 different variables for that. The more efficient way, supported by almost all programming languages, is an array, where you can declare you need to specify the type of an array and then the size of the array. These are the two important things. So for example, if you need variables of character type, to store the grades like grade A, B, C, D, because we use the characters A, B, C for the grading, then you can define depending on how many values you have. If you have 40 values, you can create an array of size 40. If you have 10 values, you can create an array of. The syntax is the same. The first thing you need to specify is what is the type of that array. And this type could be primitive type, and it could also be the reference type. You can create an array of the basic data types, and you can also the classes. And then the important thing is this square bracket symbol. For example, when we write on the whiteboard integer age, we did not put this bracket sign, because if you put that bracket sign over here, the square bracket, it indicates to the Java compiler that this is not a simple variable, but this is a variable. You want to specify that this will be an array, and then you specify the identifier, and this part is again an optional. You can create an array type, a reference variable of array type, but you cannot, you have not assigned any values to it yet. Another way is, and you also have not specified the size of it yet. And also an important thing is that arrays are internally represented in Java as an object. So this is why you see that when you create an array object, you often use this new keyword that we use to create the objects. Okay, and then you specify the size. For example, here this thing seems to be some typo over here, so you just ignore this thing. I will remove it before uploading slides. So this is string is the type, and then you have this square bracket. So here you have just created a reference array type reference variable, but you have not created any object. You have not specified the size. If you want to use this one, you have to specify the size, like we have done it over here, new int 7. So what this will do? This will create, for example, if you see in the here, if you have specified the size as a 10, okay, then it will create 10 areas or the buckets in the memory to hold the 10 elements or the values of the type that you have specified in the array definition. If you have specified the type integer, then you can, with the size 10, then you can store 10 different values in that array, but those values should be of the type int. If you have specified a type of long, you cannot store the values of type character into that, or some other which is not compatible to that type. Sometimes because you know that we have numeric types which are automatically converted it, of course. So you can store those values, but not all the different types. And how those values are, because we have not created 10 different boxes, like we have for depending on the size of that. And every that box, every element of an array has its own unique index value. And that index values always start with the 0, number 0. So the first element in an array will have an index value of 0. If you have an array of size 10 and you start from the 0, it means the last element in that array will have an index equal to 1 less than its size, because you are starting from the 0, you are not starting from the 1. Okay? So, if the size of your array is 10, then the index value of the last element will be 9 and not 10. Okay? So, it's important that if you want to accessing. So, and if you want to assign some values into this array, so for example, let's see if we have some example program over here. Yeah. So, if you see here, we have simple an integer array, int array. Here we have just declared that this reference variable is going to be of type integer. We have not specified its size yet. You can define the size together with that definition, but that's not mandatory thing to do. But then we specified that this will be of size 10, and later on, if you want to assign the values, if you want to put some data into that array, you have to specify at which index you want to store that value. Do you want to store it at index 0, index 5, 2, 3? And the one way to do that is you can use it one by one in one statement. Okay? Other ways, there could be other ways as well. We will see later on that if you have a similar kind of statements that are being done again and again, maybe you can use some iterative statements. And often we use them when we are working with the arrays to, for example, to access the values, to print the values of an array. And there could be maybe another one. And also, you can also initialize, because in the previous example, we created an array, we specified the size, but we did not initialize the values. Okay? You can also initialize the values to array when you create it. And how can you do that? You can do it, for example, we want to create an array that stores names of all the students in a class. So we know that we have maybe 5 or 10 students or 20 students. So we can create an array and specify the size, and then we can assign the names later on. Another way could be that when you create an array, at the time of creation, you can specify the initial values. And you do this by using this curly braces, like the middle braces over here, and then specifying the values separated by the commas. Since this is an array of strings, so we are passing the values as strings. If you want to create an array of integer, then you don't need this double quotes. You can specify the numeric values with comma separated list. And in this case, you don't need to specify the size as well. The size will be automatically computed by the compiler by counting the number of values. If you have passed the values like 3 values, then the size will become 3. If you pass 100 values, the size will be automatically computed as 100. You don't need to specify that thing. And when it comes to the array, we have different types of arrays. We have a one-dimensional arrays, we have a two-dimensional array, and even more than two-dimensional arrays can be possible. But we usually work with 1 or 2 or maximum 3-dimensional arrays. It's hardly a case when you need more than 3-dimensional arrays. What does it mean by one-dimensional and two-dimensional arrays? So for example, if you have a list of values, that are growing only on one axis, like y-axis or horizontally or vertically, then you are only in the values in one, like a list of items. It's only in one dimensions. But if you have like a table where you have a rows and columns, then you have two different dimensions. The rows is one dimension and the column is another dimension. Okay, so in that case, you need multiple indexes. So for that kind of data, you can use two-dimensional arrays. Okay. And how do you define them? We define them by putting, instead of one square bracket, by putting two square brackets. That tells the computers, that the compiler, that this is not a simple array, this is instead a two-dimensional array. There will be columns and rows, the two different index values. I mean, they are not actually, the terminology is the index values, so, but we can compare them to the tables, the rows and columns in a table. And then you also have to specify the size, similar to the one-dimensional array. Okay. And the process is quite same. Like, in order to access values in one dimension, in one-dimensional array, you need the index value, like 0, 1, 2. And the same goes with the two-dimensional arrays. So in this case, we say that D1 is equal to 2 and D2 is equal to 4. So it will create an array with 2 rows and 4 columns. So basically, there will be 4 multiplied by 2. We can store 8 values into that. Okay. So yeah, maybe we can use the whiteboard again. Sorry, guys. So we said that if we have a one-dimensional array, we put one square bracket. But if you want to create more than one-dimensional array, the number of dimensions you need, you have to specify as much number of square brackets over there. If you need a two-dimensional array, you put two square brackets over there. And then you put the name of the array, for example, 2D over here is equal to, similarly, as we said that new integer, we can say the size. For example, I say that 2 by 4, and then semicolon as a statement terminator at the end. If it was only a one-dimensional array, as you saw in the lecture slides, it will create only an array in one dimension. But since it's a two-dimensional array, then maybe another dimension goes. It could be understandable more logically if you saw it like a table. In this case, we have two rows, 0, 1, 2, and then we have 4 columns, 0, 1, 2, and 3. So we don't need the last one maybe. Okay, and now to access these elements, how can we access these boxes? So if, for example, if I want to put some value over here, like it's an integer value, like I want to put 20 in this box. So what is its row index? 1. So I can use it 2D, the first index 1, second index again 1, and if I put 2, 3 is equal to this, so this value will go to this position. And if you try to access if you put something that doesn't exist, because you put the index value 4 and the maximum index for the row is 2, in that case you will get some exception, you will get an error that array index out of bound. You are trying to access something and access an index value which does not exist. Okay? So your index value should be always within the size of that array. Is it clear? Yeah. And if you look at this code over here, I'm using an iterative statement for loop to assign the values, because you see that this I and j values, we can control them through the iterative statement through some loop, because these are the values that change. Every time we assign a value, these index values change. So this outer loop we have, it starts from the 0, because the first index will always have a value 0, and then it runs to the length. Okay, 2D dot length. This is an array property. Of course, you can specify the size of your outer array here, but you can use because I told you that the arrays are implemented as objects, and on the objects you have some attributes and behaviors are the methods. So the Java language provides you this dot length property for all the array objects. So in that case, if you have the first index is 2, so that length will be the 2. So that loop runs from 0 until less than 2, and then you plus this I value. So the first time this loop runs, the value of I will be 0, j will be 0, and then you check 2d.i.length. So here 2d.i, the value of I, it means like the first column, and that's the maximum value is in that case 3. And then you use this index values to assign the values, and you go on, okay, to assign those values. There is an example program given. I will put that example program together with the lecture slides, so you can play with that, and if there is some confusion, we can discuss it. The last part of today's lecture is, I don't know how much time we have. We are already near the ending time, but since we have a lab session after that, so I can take a margin of 10-15 minutes to use that one, okay, with your permission, of course. The next thing that's important with any programming language is that since we have now you see that when you are working with the arrays, you often are doing a similar things when you are assigning a value to 10 elements in an array. For example, if we look at the code over here, basically in all these 10 lines, we are doing a same, I mean, it's not exactly the same, but the nature of the job is same. We are assigning a value, okay? So instead of doing this thing one by one, Java provides us with some special statements with the name of iterative statements that we can use to do a thing in a loop again and again. If you want to do, if you have a requirements to develop an application which perform a similar kind of an activity which repeats an operation, of course it should not repeat always, because then it will be like an infinite kind of an operation depending on some condition. Until that condition is true, it should keep on until the value of something is, until the control variable is less than the maximum size of array. You should do this operation. Okay. So for this kind of things, we have the one kind of control statements that we call iterative statements. And then also sometime we also have a condition. We also have a conditional operations. We want to do something when something happens. If it doesn't happen, then our program should not do anything. Okay. For example, it should compute an interest value or the tax value if a salary of somebody increases or exceeds 20,000 or something like that. Otherwise, we don't tax this guy. Okay, so we could have different conditions. If the speed of a car is below the threshold, we don't issue a overspeeding ticket. We issue the overspeeding ticket only if the guy is violating the speed limit. So in real life, we have conditions. And since we have problems from the real life, and to simulate those things, the Java language provides us with the special set of instructions in the form of control statements. And those control statements, as I said, they are classified into 2-3 major groups. Okay. The first one is the selection statement. Then we have iterative statements and the branching mechanism. Like they are actually, related to the above two ones. If and if else, as the name says, these are like conditional statements. Okay. If something happens, do this. If it does not happen, okay, do this. If it's raining, I will stay at home. If it's not raining, maybe I will go for a walk or something like that. Okay. So the syntax of if is here, like you write the if keyword, and then within the parentheses you specify the condition. And this condition is like the Boolean expression. The Boolean expression is an expression that should end up with a true or false value. If you write something other than Boolean expression, like 2 plus 3, which is not a Boolean expression, it's like maybe then your loop condition will, the selection statement will not work. So for example, here we have an example. So we have a marks, integer marks, and if it's greater than equal to 40, then it should print pass, otherwise it should fail. And also this else part is an optional part. Okay, it's not really needed, but often when we have an if condition, we often also have a alternative part. If the condition does not happen, what should a system do? And we can also use if within an if, multiple if else. Okay, if you have multiple conditions, if this happens, if this happens, if this happens, then system should do, otherwise it should not do. In that, you can combine them. So, okay. So for example, if marks greater than equal to 90, grade is equal to this. Else, and then in the else part we have another condition. So you can use any number of conditions within if or within the else block. The example of this will be also uploaded together with today's lecture. So I think it's here. So I will upload this together with the lectures. Okay, so you can just play it, although it's not a very advanced one. Then we have an alternative switch statement. the thing that you can do with the if-else, or the multiple if-else, because in the if-else we have different possibilities, we have different cases, case 1, case 2, case 3. Okay? If a student, either student will have a grade A, grade B, C, D, E, F. We have 7 different possibilities. Those possibilities, I mean, they can be handled using if-else and could also be used using the switch one. And the switch statements, the syntax is like you use the switch keyword, and here you can use expressions other than the Boolean expression. The difference between if-else and here is, like in the if-else you can use only the Boolean expression, but here you can use the numeric expression. Any primitive type expression can be used here as well. And then you can define the different cases by using the case values, the case blocks. So for example, if we look at an example program for the switch statement, here we have an integer type value day, and depending on the value of the day variable, we assume that we have the codes for the days, like Monday is equal to 1, Tuesday is equal to 2, and so on. Then we can use, for this kind of situation, we can use a switch statement. In this case, it will start from the first statement, day 1, and this value stored in the day will be matched to these cases. For example, now the value is 1, so the first case will be matched. And only, remember that, only if you don't put the break statement, then it will continue to follow all other following statements as well. If you want to restrict this one, then you have to put a break statement after that case. And also, for example, now if you put the value 7, if the day has a value 7, so it will check this one, case 1, it does not match with the 7. So this will not execute it. It will go to the next case. 2, not matched, not executed. 3, 4, until it goes to 7. Here it matches. But if you have some other value in the day, like 10 or 0, and none of the cases has been matched, then you can have a default case that will run always when none of the other cases matched. And again, if you don't put the break statements, the code will be continued to follow up the following cases unless it finds end of the switch statement or it finds some break statement. Next, we have the iterative statements. So these were like selection statements that using if and else or using switch statements, you can select which part of your code should execute. Okay? When the if executes, the else will not execute, and if the else executes, it means the if condition has failed, so the if part will not execute. So that's why we call them selection statements. So you can choose between the parts which part of the program should execute. But then if you want to execute the same part more than one time, because in Java we have a sequential execution, with the main will start from the first statement and it will continue until the end of the statement one by one. Okay? But for some reasons, if you want to repeat a part of the program several number of times, 5 times, 10 times, 100 times, then you can use iterative statement. And in the iterative statements, we have basically 3 different kinds. These iterative statements are often called as loops because they are like, they play like a loop again and again. We have a while, we have a do while, and then we have a for. And nowadays, in the latest version of the Java, there is another for each loop as well. But if you learn these 3, you can do the same thing with the for. It's basically a syntactic sugar for a for loop. It's not actually something new. So, the syntax for the while statement is that you use the while keyword, and then within the parenthesis you specify condition. When should this loop execute? It will execute only when that Boolean expression will be true. If that condition becomes false, your loop will not execute. Okay? And then we have a do while loop. The difference between while and do while is, you can see it already here. In the while, the expression, the condition, the Boolean expression that is used to control the loop comes first, and then comes the body of the loop. But in the do while, the body or the statements comes first, and the Boolean expressions comes at the end. So it means the do while loop will always execute at least once, even your condition becomes false in the first attempt, in the first execution. It will always execute at least once. But on the other hand, if your condition becomes false, if your condition happens to be false in the first attempt, the while loop will not execute even at once. Okay? So for the while loop, it is always mandatory that condition should be true. But for the do while, it will execute once and then check the condition. And then if the condition is true, it will run again. But if the condition is false, it will stop after running for the first time. Sorry. Okay. And then we have here we have an example given here, so you can just look at this example. So, and it's not something complicated, but if you get a questions, we can see the example later on as well. And then we have a for loop. To me, the for loop is basically quite same like a while loop. It's only like some additional things added on. So, for example, in the for loop, we have a for keyword and then the parenthesis. In the while, we have a Boolean expression. Okay, but here we have initialization part. In the initialization part, for example, if you want to do something before a loop execute, it gives you an opportunity that if you want to initialize, if you want to do some operations before the body of the loop executes, then you can do that in this initialization part. But it's not mandatory. You can leave it empty as well. You can just simply put semicolon, and you can do that initialization even above the for loop, out of the for loop. So the first part is here. You do the initialization. For example, you do the variable. I mean, important thing with the loops is that you should have a control on that loop. And what does it mean by that your loop should come to an end after some iterations, after 10, 100, thousands, millions. If it does not come to an end, it will be an infinite loop, and it will keep on running. I mean, if you have valid reasons to have an infinite loop, maybe you can have that one. But on your home computer, you will not imagine to have a loop running on all the times. So, and to control that, the variable that we use in the conditional part to control the execution of a loop, we often call it a control variable that controls the execution of a loop, whether it's a while loop or a for loop. And normally, when we are using the for loop in the initialization part, we assign initialization of that control variable. In this case, we are using this integer n, and we are saying that the initial value of n is equal to 1, and then we want to run this loop until the value of 1 is less than or equal to 5. You can specify this thing as a condition over here. So the first part is initialization, the second part is condition expression, The third part is the statement, body of the loop. It might look like after this the control will go here, but in execution, in writing you write this first, but in execution after condition it will check the value of, now what is in the end, the value of n is 1, it will check the condition, 1 is less than equal to 5, the condition is true, it will jump here to the body of the loop and to the next statement, okay, and then execute this statement or the body of the loop, and after the execution it will go to this part which we call it update, or sometimes they call it increment, decrement, the control variable, okay. And in this part we increment the value of n by 1, okay. It could be any condition, it could be any statement that changes the value of it. If it does not change the value of, then loop will remain always executing. So now the value of n becomes 2, and from here it will go back to the condition part. So the initialization part will run always only once at the start of the loop, and then after that it will keep on running in this loop, condition, statement, update, condition, statement, update. So 2 is still less than 5, runs 3, 4, 4 is less than equal to 5, okay, condition is still true, it executes the loop statement. Now n becomes 5, comes here, 5 is equal to 5, still it's equal to 5, it's not less than but it's equal to 5, okay. 6 is neither less than not equal to 5, condition becomes false, so loop will come to an end. Is it clear? Then the last two, break and continue. Quickly, if you want to, for some reason, if you want to interrupt your loop based on some values in your program, you can use the break statement, okay. Whenever that break statement will execute, it will stop your loop and the control will be shifted out of the loop to the next statement that is followed. But sometimes you want to skip the current execution but not the whole loop. If you want to skip the current execution of the loop, then you use the continue statement. All the statements that follow the continue statement within the loop will be skipped, but your loop will still remain in process. So that's the difference between continue and the break statement. Break will stop the whole loop and passes the control out of that loop, maybe to the next statement or to the outer loop or other statement. But on the continue, if you use the continue statement, if you want to skip only the current execution and not the whole loop, then you should use the continue statement. That's the fundamental difference between the two. So then this brings us to the end of today's lecture, which was a bit over the planned time, but I think it was because the first lecture and we have some introductory things into that. On this slide you find some suggested readings, some online tutorials and some of the books. We don't have any specific book, recommended book. You can use any Java book that covers the content, so it's up to you. So the next lecture we will talk about object-oriented programming, what are the classes and objects, and the different features related to the object-oriented programming and the key principles of object-oriented programming. So it will be nice if before coming to the next lecture you can look at these things. Otherwise, it's bye from me, and maybe you guys can have 10-15 minutes break. It's up to you, or share a loss, and then you can continue with the lab session. And if you have questions before that, I will be here for 5-10 minutes. Okay.